right, we're going to find the graph. We're going to graph this conic and identify any vertices and foci of it. Like the other problems, when you're first looking at a conic section, given the implicit form, you need to identify what type it is. We have parabolas and ellipses and hyperbolas. Those are the basic common ones. And also you have circles. But for this one, the first thing is you want to identify how many different squares there are. So we have two different squares. Okay, so either it's a hyperbola, or sorry, ellipse, or a hyperbola. Hyperbola. Now with an ellipse, the two squares are always going to be positive. Positive. Hyperbola, one of them is going to be negative. And when you identify this right here, you notice that you do have a negative value. So because you do have a negative term, all right, the hyperbola is the one you're going to be using for today. All right, so we're going to have the hyperbola right there. And let me get rid of this. Okay, because we have the negative, so let us find out what this hyperbola is going to be. Now, the hyperbola can come in many different forms. The key thing is identify which one is going to be positive. And we notice the x squared is positive, so that's going to be our transverse axis, which is like our major axis. Okay, so we're going to use x minus h squared, and this is going to be our a squared minus y minus k squared, or b squared equals 1. Now, the one thing that's different between a hyperbola and ellipse is, besides the difference, which is right there, is that the a and b do not necessarily need to be, a doesn't necessarily need to be bigger or larger. Okay, that only works for ellipses. So that's one of the key things. So from here, we're going to, first off, to graph this and identify vertices and foci, we're going to first go through and write that into standard form. Okay, and this is our standard form right here. Okay, so do so. We're going to take this and we're going to combine our like terms. 4y squared equals 0. Okay, now from here, we're going to group everything together. And what I have is we're going to have x minus 4x, and I'm going to complete this square. And if you recall, c has to be, take the b value divided by 2 and squared, and so we're going to have 4. Now, whatever I do with one side, I have to do the other, so I'm going to add 4 to this side. Now we have 4y squared. Well, that's already completed, and so we have this. All right, so from here, we're going to now, all right, write out our equation. So we have x minus 2 squared minus 4y squared equals 4. Now, a hyperbola, like an ellipse, has to have the one side equaling 1. So we're going to multiply both sides by 1/4. We can eliminate that. All right, make that 1 on that side. So we have x minus 2 squared over 4 minus y squared, I'll just put 1 there, equals 1. Okay. Now from here, we're going to now do our graph. Now, first thing when you're doing a graph of a hyperbola, and I'm going to take this right here, move it over there and shrink it down a little bit. So we have that. I'll take this 2, those together. I'll make that a little smaller as well. Okay. So with this, we're going to take this and we're going to identify our different various things. So we're going to first find, like an ellipse, we're going to find our center. Our center is always going to be located with the h and k. So that's the h and k. Once again, the h is the x, the k is the y. So in this case, our center is located at 2, 0, 2, 0. So I'm going to go over here and graph that. All right, our center is going to be at 2, 0. So we go 1, 2, and 0. So we have that right there. Okay, so now next thing is we want to identify our transverse axis. All right, axes, which in all intents and purposes is like a major axis, even though they don't call it the major axis. All right, now from here, our major axis is going to be whatever the positive value is. Now in this case, x minus 2 squared is positive, so it's going to be a horizontal axis. Okay, so here, this is going to be our transverse, and it's going to be a horizontal then, because x is excuse me, hyperbolas always go either horizontally or vertically. Traditionally, they always go horizontally, unlike parabolas. So from here, what we're going to do then is now we're going to find our a value, because the major is our a. So from here, we can see that a squared equals 4, and our a value is going to equal 2. So that means we're going to go 2 units, 1, 2. Here's one vertice, will be 1, and that point's going to be 4, 0. And then we're going to go another point over here. It's going to be V2, which is going to be 0, 0 at the origin. Okay. Now, from here, we're going to next, what's going to probably help us out a lot, is we're going to now identify, to graph this out, we're going to identify our minor transversal axis. All right. Okay. And our minor is going to be b units from the center. Now, our b value, b squared equals 1, and b equal 1. And so what we're going to do is from here, we're going to go like this, and we're going to draw and go 1 unit up here, 1 unit down there. And what we create is actually, this is what's a little bit unique, all right, about hyperbolas, is what we create is this rectangular box. And that rectangular box has a purpose. The purpose is that it creates, allows us to identify where our asymptotes are. Because our hyperbolas have 2 distinct linear asymptotes. They're asymptotic. And the asymptotes, so what we're going to do is from here, the fourth thing to graph it, is we create the box. All right, box and asymptotes. All right, and they are the diagonals that pass through these. All right, and that is what we have right there. So from here, we can see, and I'm going to now be doing green, so just looks a little different, is from the vertices, we're going to have this hyperbola that goes along these asymptotic lines from here and right there. And that's our hyperbola, and that's it. Okay, we found it. So from there, we have, we created our boxes and our asymptotes. If you wanted to find the equation of these asymptotes, the equation is simply going to be the equation of a line, since they're both lines. All right, even though it doesn't ask us to do this, but it's going to be y equals, all right, plus and minus. And when we go is from the center, all right, to figure out our slope, because we're going to be using this slope, and it's going to be x minus h plus k. All right, where this is the center, and then we have our slope. So we look at our center. Our center, once again, was at 2, 0. So we're going to go x minus 2. And we have 0 there. And now we got to find our slope. Now, what I normally do, instead of memorizing this, I look at my center point, and I say, OK, I'm rising how much? Because slope is rise over run. Okay, hopefully you know that. Slope, rise over run. Difference in the x's over difference in the y's. All right. Y, change x, all that cool stuff. So I'm rising how many units? Well, in this case, it's the b units. So for this one, we're going to have b over, is b, in this case, is the vertical, all right, over a. Okay? It changes depending on how the asymptote's going to be. I just think about always rise, how many units? 1, over my run, which happens to be, in this case, 2. So I have a slope of 1/2, and that's my equation. Plus or minus, because we have a positive 1 right here, and we have a negative 1 right there. All right, and we go along with that. All right, so get rid of that. Okay, so that is how we can create and find our asymptotes. Now the final thing is, according to the problem, is we have to find our vertices, and now we have to find our foci. All right, our foci. I say it 2 different ways. I apologize for those that are annoyed by that. Now, to find the foci, like in an ellipse, all right, is on the transverse axis or major axis. Okay, major axis. All right, and to find this, it's c squared, a squared, not minus, but actually plus b squared. So it's like the Pythagorean theorem, but completely different. Okay. What we're going to do is to identify this, the foci are going to be on inside the parabola itself, just like or inside the hyperbola or the parabola part of it. So to do this, we're going to take all our values. So we're going to take our a squared, which is 4, and then we're going to take our b squared, which is 1, and we find c squared is going to equal 5 in this case, and so c equals the square root of 5. So that means, all right, is going to be c units from the center, just like an ellipse. So we're going to go c units from the center, which is approximately, we said this again, which is 2.23. So our foci are going to be right here. So from the center, 2.23, 1, 2, 3. So about right there, and about right there. And to find out these points, we can write these out. Say this is F1. F1 is going to be, well, we're going to take 2, plus, all right, the square root of 5, 0, and then our foci 2, which is right there, okay, is going to be 2 minus the square root of 5, 0, and that will be our 2 points. All right, so there are a lot of similarities between an ellipse and a hyperbola. Okay, the c value is, once again, from the center to the foci. All right, and we can use this equation. You just got to remember it's going to be a squared plus b squared, unlike ellipse. That's how you can find the foci. A hyperbola, one of the differences is that it does have a asymptote that you have to create a box by using the minor and major values. Okay, major and major values. We create this box, and that gives us our asymptotic lines that we can sketch our parabola with. Okay. One other key feature is that we also have to find the center. Okay, we have to find the center. All right, which is easily found when we finally put it into standard form. Well, so that's a hyperbola. Hopefully this makes sense on how to identify and how to write all those out. Hope this helps, and good luck on the rest of your problems.